Hello and welcome back to Crystallography for Everyone. In the last video, we saw how we can construct a one-dimensional lattice according to our definition up here, a periodic array of points where each point is indistinguishable from any other point and has identical surroundings. We covered a lot of ground with a simple one-dimensional construct. But in this video, we're going to go further and construct a two-dimensional lattice. So I've already drawn a grid here, and we can imagine if we just focus on the bottom row here, I'll draw in our lattice points once again. We can imagine it's extending off in two directions. Here's where we ended off in the last video. Now I can start building these layers. I can start stacking these layers. I can start adding points the next layer up, and one after that. And you can imagine how this could also extend off to infinity in two different directions. We can define the same lattice translation vector that we had before. We can define the lattice translation vector A. But what you notice is the vector A does not tell us anything about the next row. So let's just label 3 of these rows, remembering there are infinitely many rows because of our definition of a lattice. There is no way using just the vector A that we can get from row 1 to row 2, or from row 1 to 1, 3. What we need to do is define another lattice translation vector. I will define a second vector here. We'll call it B. This is our second lattice translation vector. And now we're in business again. Using a linear combination of A and B, we can get to any other point on the lattice. Start off to get to this point. So I'll define another position vector. Call that R1. Add the vector symbol in. R1 is 1 times A plus 1 times B. So we've navigated between these two lattice points using our two lattice translation vectors in a linear combination. We could define our general lattice translation vector once again. In the last video, all we needed was U times A, where U is an integer. Now, we will have V times B. So we have our two lattice translation vectors A and B, and U and V are integers. They are not necessarily the same integer. In this case, they are, but we could go to any other point. We could take this vector, and in this case, call this R2, draw it here. R2 equals 2A plus 1B. And we could get to any other lattice point with integer values of u and v. You'll notice that these layers are not stacked directly on top of each other. We have a decision that we can make. We can change this angle here. We'll call it the angle alpha. Alpha could be 90 degrees, could be 60 degrees, it could be 30 degrees, it could be anything. Alpha is what is going to determine the type of lattice that we have. In the next video, we are going to go through the different types of 2D lattices. And they're going to depend on the relationship between A, B, and alpha. I hope to see you there.